What if the greatest secret of the cosmos is not found in light, but in the places where light is absent? In the late 20th century, as humanity built new instruments to chart the heavens, a revelation began to unfold.
Ow.
For centuries, the night sky had appeared as a glittering ocean of stars, each point of light suggesting an endless uniform spread. But the deeper astronomers looked, the more structure revealed itself in the 1970s. Teams of scientists undertook the first great surveys of the universe. The CFA Redshift survey sought not only to record where galaxies shimmered on the sky, but to map their true positions in 3 dimensions. With each measurement of distance, the cosmos was transformed from a flat canvas into a living structure. A web of matter stretched across unimaginable scales. What they found was not the smooth, even distribution that theory had predicted. Instead, galaxies gathered like dew along invisible strands. They traced immense filaments, clustered in walls and arcs, closing vast and silent hollows. And in 1981, Robert Kirshner and his colleagues stumbled upon one of the most extraordinary of these hollows. Within the constellation of Boats lay a region so immense, so nearly devoid of galaxies, that it seemed to challenge the very order of creation. Hundreds of millions of light-years across, yet containing only a scattering of lonely worlds at first. Some wondered if this was a trick of observation, an artifact of incomplete data. But as maps grew clearer, the truth emerged. This was real. A cavern of near-nothingness within the cosmic web. The Boat's void, it was not a gap to be ignored. It was a discovery that forced science to confront a haunting question. The universe, in all its brilliance, carved out a realm so profoundly empty. The discovery of the Boat's void was not simply a footnote in astronomy. It was a revelation that shook the foundation of cosmology. A revelation so vast that it forced scientists to question their most basic assumptions about how the universe is built. In the years leading to 1981, astronomers were piecing together a new portrait of the cosmos. Galaxies were no longer seen as isolated islands floating randomly in the dark. Instead, surveys were beginning to reveal a hidden order, a cosmic architecture. Galaxies aligned in strands, walls, and arcs, weaving together into what would later be called the cosmic web. Between these luminous structures, there were pockets of relative emptiness. But nothing had prepared scientists for the scale of the void they were about to uncover. The Boat's void, mapped and confirmed in the early 1980s, stretched across nearly 330 million light-years. To put this in perspective, if our own Milky Way galaxy had been placed inside this vast cavern, it could travel for hundreds of millions of years at near the speed of light before encountering another cluster of galaxies. This was not a small pocket of space missed by matter. This was a staggering emptiness, one of the largest structures or anti-structures ever observed. The sheer size of the Boat's void was a contradiction to expectation. For decades, cosmology had rested on what is known as the cosmological principle, the assumption that, on large enough scales, the universe is uniform and homogeneous. While small clumps of galaxies could form locally, the overall picture was thought to be smooth, like mist filling a room. The Boat's void stood as a direct challenge. It was not a minor irregularity. It was a vast hole in the tapestry of existence. The shock deepened as scientists considered the processes that shape cosmic structure. According to models of structure formation, matter in the early universe began as tiny fluctuations in density, etched into the afterglow of the Big Bang, visible today as subtle variations in the cosmic microwave background. Over billions of years, gravity magnified these fluctuations, pulling gas and dark matter together to form galaxies and clusters. The expectation was that the universe would resemble a rough but fairly uniform distribution, with no region deprived of galaxies on such an extraordinary scale. And yet, here was the Boat's void, an immense region that seemed to escape the gravitational game entirely. A cosmic desert where matter had failed to gather. Two scientists trained to see the universe as balanced and predictable. This discovery was disorienting. The void was not a mistake, not a miscalculation. It was a natural part of the large-scale structure but its sheer magnitude stretched the limits of what theory could explain. Some began to compare it with the largest known features of the universe at that time, the Great Wall of Galaxies, spanning hundreds of millions of light-years, or the Perseus supercluster. But where those were tapestries of luminous brilliance, the boat's void was an abyss. If the Great Wall was a symphony of clustered matter, then the void was silence, and it was not just empty of galaxies, even. The few galaxies discovered within its borders were peculiar. They seemed faint, dimly lit, as though the environment itself suppressed the formation of vibrant stellar populations. These lonely galaxies, marooned in the dark, were anomalies inside an anomaly. They deepened the sense of mystery rather than resolving it. The shock rippled outward through the scientific community. Could such a void exist within the framework of Einstein's general relativity? Did dark matter, the invisible scaffolding of the cosmos, behave in unexpected ways? Was the universe hinting at a new principle entirely, one not yet written into the laws of physics? At its core, the discovery carried a philosophical weight. Humanity had long wrestled with the vastness of space. But this was different. Vastness was expected. Emptiness of this magnitude was not. To confront the boat's void was to confront the idea that the universe is not simply immense, it is profoundly empty. The emotional impact of this revelation cannot be overstated. For millennia, people had looked to the stars as symbols of abundance, a sky filled with promise. But the void whispered a different truth. The majority of the universe is not filled with light, but with nothingness. The galaxies that dazzle. Our telescopes are but fragile threads stretched across gulfs of darkness. In this sense, the boat's void is not just a scientific anomaly, it is a cosmic reminder of proportion. For every cluster of galaxies, for every radiant supernova, there are regions of silence so deep that they dwarf creation itself. The scientific models began to adapt. Computer simulations of the cosmic web grew more sophisticated. Physicists fed the equations of gravity, dark matter, and cosmic expansion into vast networks of algorithms, allowing universes to evolve inside digital memory. And there, in the language of simulation, voids began to appear naturally. They were not mistakes, they were consequences. But the boat's void still stood apart, near the edge of plausibility. Most voids in simulations were smaller, mere tens of millions of light-years wide. The boat's void seemed to exceed the ordinary patterns. It was a statistical outlier, a silent cathedral at the edge of comprehension. Speculation bloomed. This void, the result of rare fluctuations in the early universe, regions where density was so low that galaxies simply never had the chance to form? Or could something more exotic be at work? Could dark energy, the mysterious force accelerating the universe's expansion, play a role in inflating these voids faster than their surroundings? Even more daring ideas emerged. Some cosmologists wondered if the largest voids might be windows into the multiverse, scars left by interactions between our universe and others. If the cosmos is an infinite sea of bubble universes, perhaps the boat's void is where our bubble brushed against another, leaving behind a barren scar. These speculations stretched the imagination but underscored the shock. The void was not just an absence of galaxies. It was a question carved into space itself. And so the boat's void became more than a discovery, it became a symbol of cosmic humility. It reminded science that, for every answer written into the stars, there are greater silences waiting to be heard. The void is not a canvas upon which galaxies are painted. It is a dominant feature of the painting itself. To stand before the knowledge of such emptiness is to feel both awe and unease. Awe at the scale of the universe's architecture. Unease at the realization that our world, our galaxy, even our superclusters, are fragile filaments stretched across a BYSSES. The shock of the boat's void continues to echo through cosmology. It forced a new perspective. The universe is not defined only by what exists, but by what is absent. Its meaning lies not only in light, but in the silence between. And in that silence, the questions remain. Why did the universe carve out such a chasm Is emptiness as fundamental to reality as matter itself? And if so, what deeper truths lie hidden in the voids that stretch across the cosmic web? As the 20th century gave way to the 21st, humanity built new eyes for the universe. No longer content with scattered surveys of the nearby sky, astronomers set out to chart the cosmos on scales never attempted before. The goal was simple, yet audacious: to trace the very architecture of the universe, to reveal how galaxies were arranged across billions of light-years, and to discover whether the boat's void was an anomaly or part of a larger pattern hidden within the fabric of creation. The Sloan Digital Sky Survey rose as one of the great instruments of this mission. From the high desert of New Mexico, its wide-angle telescope began to sweep the heavens systematically. Night after night, the data accumulated. By the time its first phase was complete, Sloan had cataloged hundreds of millions of celestial objects, including over 1 million galaxies with precisely measured redshifts. It was the first time that humanity saw the cosmic web emerge in such detail, and it was not alone. The 2DF Galaxy Redshift Survey in Australia expanded this vision, capturing the distribution of over 200,000 galaxies, stretching across deep cones of space. Later, the Dark Energy Survey joined this pursuit, probing still farther, mapping galaxies and clusters in order to understand not just their positions, but the mysterious force accelerating the universe's expansion. What emerged from these efforts was a portrait unlike anything imagined in earlier centuries. Galaxies were not scattered like dust in the wind. They were threads in a grand design, strung along invisible filaments, woven into colossal walls. It gathered in luminous nodes where clusters collided. Between these glowing structures yawned the void's immense regions with far fewer galaxies than the average. Together, they formed a network, a cosmic web, stretching across the observable universe. The boat's void was no longer alone. Other voids were revealed, some spanning tens, even hundreds of millions of light-years. These discoveries confirmed that emptiness was not an accident but a defining feature of the cosmos. The universe was shaped as much by the hollows as by the walls of galaxies enclosing them. And yet, even among this menagerie of emptiness, the boat's void remained extraordinary. With a diameter approaching 330 million light-years, it stood among the largest single voids ever observed. If one were to compare, the local group, the tiny gathering of galaxies that contains our Milky Way, is scarcely 1/100th of its size. The scale is so vast that light itself takes 300 million years to cross it, longer than the age of mammals on Earth. Why should such a void exist? To seek answers, cosmologists turn to the laws of physics and the silent architects of structure, dark matter, and gravity. In the early universe, matter was not evenly spread. The afterglow of the Big Bang, the cosmic microwave background, shows faint ripples in density, no stronger than 1 part in 100,000. Over time, gravity magnified those ripples. Dense regions grew denser, pulling matter inward, while less dense regions were starved, their contents drawn away. Into the forming web, computer simulations, run on the world's fastest supercomputers, recreated this cosmic evolution. Virtual universes blossomed inside silicon memory, obeying only Einstein's relativity, the laws of thermodynamics, and the mysterious presence of dark matter. The results were astonishing. Out of simple initial conditions, the same vast web appeared filaments, clusters, and voids. Voids, it seemed, were not unnatural. They were the inevitable counterpart to creation itself. For galaxies to form in one place, there must be hollows elsewhere. Emptiness was not failure, but balance. And yet the boat's void resisted easy explanation. Most simulated voids were large, but not that large. The sheer size of this cosmic chasm made it a statistical outlier, a rare and improbable structure even within the rules of gravity and dark matter. Some cosmologists argued that its scale might hint at more subtle physics, perhaps the influence of dark energy in stretching low-density regions faster than others, or the ghostly fingerprints of cosmic inflation. The brief but violent expansion in the universe's first trillionth of a second, even more haunting, were the galaxies found. Inside it, They were not entirely absent, but they were few, scattered like embers, fading in a dark sea. Observations revealed them to be faint and isolated, far from the nurturing presence of clusters and filaments. Star formation in such galaxies appeared sluggish, their light dim compared to those thriving in crowded regions. In the silence of the void, galaxies struggled to ignite and sustain brilliance. For astronomers, these lonely galaxies became living laboratories. What does it mean to evolve in isolation, cut off from the cosmic web's exchanges of matter and energy? Could these void galaxies hold clues about what stars and galaxies become when left adrift in the abyss? The boat's void was no longer just a gap in the sky. It was a frontier for questions science had barely learned to ask. If voids are natural consequences of cosmic evolution, why should one grow to such an outsized scale? If galaxies inside them are faint and rare, does this tell us something fundamental about the conditions necessary for life, for structure, for meaning itself to arise? The deeper the investigation went, the more the void revealed itself as a paradox. On one hand, simulations confirmed its place in cosmic architecture. On the other, its immensity defied comfort, reminding humanity that the universe is not generous with light. It is a web stretched thin across gulfs so deep that even time itself seems swallowed. And in this silence, a profound reflection lingers. The universe is not a grand cathedral of stars alone. It is also a cathedral of absence. Its architecture is built as much by voids as by galaxies. And within that balance, the boat's void remains one of the most haunting structures of all. A reminder that creation itself is sculpted not only by what exists, but by what is missing. The boat's void is not merely an emptiness in space. It is a paradox written across hundreds of millions of light years. A question that continues to deepen the more it is studied. At first glance, one might expect that galaxies would always appear with some regularity, even across large scales. After all, matter in the universe is governed by the same laws everywhere. The tiny fluctuations left behind in the afterglow of the Big Bang were nearly uniform, their differences no larger than a whisper in a storm. From such near perfection, the cosmos built everything that exists. Galaxies, stars, clusters, all emerged from ripples that were almost too small to notice. If nature began with such delicate balance, then why should there be a cavern as immense as the boat's void? Why should the cosmos carve out a desert so wide when theory predicts a more modest landscape of emptiness? The puzzle is profound because the void does not simply reflect absence. It reflects something active, something dynamic. Matter flows away from regions of low density, pulled relentlessly toward the gravitational embrace of filaments and clusters. In this sense, voids are not passive gaps in the cosmic web. They are expanding entities, growing larger as they evacuate their already scarce contents. Some theorists argue that this expansion is faster than the growth of the universe itself. In a region where matter is sparse, gravity exerts less restraint, and the natural expansion of space proceeds with fewer obstacles. The result is an acceleration of emptiness. Galaxies drift farther apart inside a void than in regions crowded. With clusters, the hollow deepens with time, the silence growing louder as billions of years pass. If this is true, then the boat's void is not just a static scar left over from the early universe. It is a living structure, a region where cosmic expansion is amplified. And if so, then perhaps voids are more than oddities. Perhaps they are laboratories where the universe reveals the true nature of its growth. This possibility unsettles the foundations of cosmology. For decades, scientists have sought to understand the mysterious phenomenon of dark energy, the hidden force that drives the acceleration of the entire universe. Its nature remains elusive, a profound mystery at the heart of physics. But what if the secrets of dark energy are etched not in the crowded regions of galaxies, but in the hollows where matter is most absent? By studying voids, some physicists suggest we might uncover subtle differences in the way space itself expands. Perhaps the low-density regions amplify the fingerprints of dark energy. Perhaps they act as magnifying glasses for the invisible. If so, then the boat's void becomes More than an oddity of structure formation, it becomes a potential key to unlocking the destiny of the cosmos. Still, the scale of the void defies easy reconciliation. Simulations predict voids, yes, but not typically of this magnitude. The boat's void pushes the limits of probability, suggesting either a rare statistical fluke or physics not yet fully understood. It is this tension between what models predict and what the universe reveals that keeps the void at the forefront of cosmic puzzles to the human imagination. The boat's void carries an emotional weight beyond numbers and equations. It is not simply empty. It feels wounded, as though the universe stretched its hand across space and left behind a scar where creation never fully touched. The galaxies inside it are scattered like solitary outposts, fragile sparks lost in a wilderness of silence. Orbit in isolation, far from the nourishing exchange of matter and energy that fuels clusters. They are survivors of neglect, not heirs of abundance. The image of this scar reaches beyond science into philosophy. If the cosmos is a grand design, why should it leave behind such barren gulfs? If the universe is an artist, why should its brushstrokes falter here, leaving behind emptiness instead of form? Or is emptiness itself the canvas, the necessary counterpart without which structure could not exist? The boat's void forces us to confront a deeper truth. The universe is not generous in its distribution of light. For every star that burns, for every galaxy that shines, there are vast oceans of nothingness. Existence is not the default. Non-existence dominates. And yet, perhaps it is in the very scale of this emptiness that meaning emerges. The void may not be a flaw, but a feature, a reminder that what seems like absence may in fact hold the keys to presence. For if dark energy, it is real, and if voids are the regions where its effects are most pronounced, then the silence of the boat's void may whisper the deepest truth of all, that the universe is not merely expanding, it is accelerating toward a future where emptiness itself will reign supreme. The mystery deepens with every observation. Instruments refine their maps. Simulations grow more powerful. Theories sharpen. But the boat's void endures as an enigma, its immensity undiminished, its silence unbroken. It is not merely a hollow in space. It is a cosmic scar, a place where creation withdrew its hand. Within that scar may lie the most profound question of all. Not simply why galaxies form, but why emptiness grows. The boat's void sits like an unanswered riddle within the cosmos, a chasm so vast that it stretches the imagination and strains the limits of physics. To confront such a gulf is to ask whether the assumptions upon which cosmology rests are as firm as once believed. For more than a century, the framework of modern astronomy has been guided by the cosmological principle. The belief that on the largest scales the universe is both homogeneous and isotropic. That is, no matter where one looks, or from where one looks, the universe should appear broadly the same. This principle is not a casual suggestion. It is the bedrock upon which the equations of general relativity are applied to the cosmos as a whole. It is the foundation of the standard model of cosmology, the Lamb-Cold dark matter model. Without it, the very mathematics of cosmic evolution begins to fracture, and yet the boat's void stares back with quiet defiance. Its immensity suggests that homogeneity may not be as smooth as once thought. Perhaps the universe is uniform only in the statistical sense, an average that conceals vast irregularities. Perhaps the principle is less a law of nature than a convenience for human equations. Within this possibility, voids take on new significance. They are not small deviations, but deep questions about the very nature of structure. And they force cosmologists to ask, if the universe is not uniform, then what truths remain hidden in its unevenness? Dark energy rises as the most compelling suspect in this mystery. Since its discovery in the late 1990s, when observations of distant supernova revealed that cosmic expansion is accelerating, dark energy has become both the central player and the central enigma of cosmology. Its effects are subtle, yet profound, driving galaxies apart with a force that seems woven into the very fabric of space itself, in regions of high density. The gravitational pull of matter counterbalances this acceleration. Galaxies within clusters hold together despite the universal push, but inside voids, where matter is scarce and gravity weak, dark energy is unopposed. Here, its influence may be amplified. Voids may expand not only with the universe, but faster than the universe. In this interpretation, the Boat's void is not a passive relic of the past. It is a stage upon which dark energy performs at full strength. Some physicists speculate that this makes voids natural laboratories for studying the dark sector of the cosmos. In their emptiness, subtle variations in expansion might reveal the fingerprints of dark energy, perhaps even distinguishing between competing models. Is dark energy truly a cosmological constant, an unchanging pressure built into space-time as Einstein once imagined? Or is it dynamic, the product of a field that evolves over time, perhaps destined to grow stronger until it tears galaxies, stars, even atoms apart? Voids, with their exaggerated emptiness, may hold the answer. By measuring how galaxies drift within them, by mapping how light bends at their edges, astronomers seek to uncover whether dark energy behaves uniformly or whether its power varies depending on the cosmic environment, and yet the puzzle reaches deeper still. Some theorists suggest that voids are more than regions of low matter. They may be windows into the quantum vacuum itself. In the absence of galaxies, gas, or dark matter, the fundamental energy of empty space may dominate. Quantum fields, which seethe invisibly even when no particles are present, might express themselves more strongly in these hollows. If so, the Boat's void could be a place where the quantum and the cosmic meet, where the smallest scales of physics echo across hundreds of millions of light years. This idea blurs the boundary between presence and absence. Perhaps emptiness is not nothing at all. Perhaps it is a reservoir of invisible forces, a stage upon which the universe rehearses its deepest mysteries. Others turn their attention further back to the earliest moments of time. In the inflationary epoch, the universe expanded faster than the speed of light, stretching quantum fluctuations into vast cosmic seeds. Some regions emerged slightly denser, giving rise to galaxies and clusters. Others emerged slightly emptier. Could the Boat's void be the remnant of one such fluctuation, an echo from the universe's first trillionth of a second? If so, then voids are fossils of the Big Bang itself. They are not anomalies, but preserved imprints of primordial randomness, scaled up to dimensions so vast they defy imagination. But speculation does not stop there. Some cosmologists have dared to suggest that the largest voids may be scars left by collisions with other universes. In the inflationary picture, our cosmos may be but one bubble in a vast multiverse. If another bubble once brushed against ours, the interaction could have left behind anomalies, cold spots, asymmetries, voids. The Boat's void, in this extreme vision, is not a gap in our universe, but a wound left by contact with another realm of existence. Such ideas remain far from proof, but they reveal the depths to which the void unsettles the mind. It challenges not only cosmological models, but the human sense of place. If voids are boundaries between different states of reality, then they are not simply hollows, they are thresholds. To look into them is to stare at the edges of what is. KNOWABLE. And so the Boat's void becomes more than a region of missing galaxies. It becomes a mirror of human limitation. It whispers that our principles may be incomplete, our theories provisional. Our understanding a fragile lattice stretched across a darkness far greater than our light. The universe is not merely vast, it is patterned with mysteries that grow. Larger the more they are studied. The Boat's void is among the greatest of these. Its scale mocks uniformity. Its emptiness exaggerates the presence of dark energy. Its silence hints at quantum depths and multiversal echoes. It is both a scar and a laboratory, both an absence and a presence. In confronting it, cosmology confronts its own limits. And humanity, gazing across the abyss, confronts the possibility that the universe is stranger than even its boldest equations have yet imagined. The voids of the universe, once thought to be little more than curiosities, have become frontiers of science. It's no longer ignored. They now stand at the center of modern cosmology, demanding precision, patience, and imagination. Secrets, humanity has turned its most powerful instruments toward the emptiness itself. The Sloan Digital Sky Survey, which first revealed the cosmic web with breathtaking clarity, continues to expand its reach. Its legacy is written across vast catalogs of galaxies, each mapped with exquisite precision, each position a point of light within a larger structure. From those maps, voids emerge naturally, carved out like shadows between luminous strands. What once seemed like an anomaly now appears as part of a grand architecture, measurable and predictable, though never fully explained. The dark energy spectroscopic instrument, or DESI, builds upon this foundation. Mounted on a telescope in Arizona, DESI is designed to chart the positions of tens of millions of galaxies, creating a three-dimensional atlas of the cosmos with a scope never before attempted. Its task is not only to measure where galaxies cluster, but also where they do not. In its maps, voids take shape with sharper edges, their expansion tracked across cosmic time. Each hollow becomes a data point, a natural laboratory for testing. Whether dark energy is uniform or variable, beyond Earth's surface, the Euclid Space Telescope has joined the search. Launched by the European Space Agency, Euclid is designed to study the geometry of the universe itself. By measuring the subtle bending of light caused by gravitational lensing, Euclid can trace not only galaxies, but also the invisible scaffolding of dark matter that shapes them. In the regions of voids where matter is scarce, these measurements grow delicate, but all the more revealing. The absence of structure is itself a signal, a whisper of how gravity, dark matter, and dark energy interact in silence. And soon, the Vera C. Rubin Observatory will open its eyes from the mountains of Chile. Its legacy survey of space and time, LSST, will record the entire visible sky every few nights, building a cinematic record of billions of galaxies and their evolution. From this staggering dataset, voids will no longer be shadows glimpsed at, the edges of maps. They will be charted in motion, their galaxies cataloged in detail, their expansion tracked with time-lapse precision. These surveys converge on a deeper truth. Voids are not absences to be ignored. They are instruments of measurement as precise as any telescope. Their emptiness amplifies subtle effects, making them natural detectors of the forces that shape the cosmos. Evidence of this comes from the cosmic microwave background itself, the faint afterglow of the Big Bang. Within that ancient light lies an anomaly known as the cold spot, a patch of sky significantly cooler than the surrounding radiation. One hypothesis suggests that this cooling may be linked to a vast void along our line of sight, stretching photons across an extended journey, sapping them of energy through the integrated Sachs-Wolf effect. True, then voids do not simply shape the large-scale structure of galaxies. They imprint themselves onto the very fabric of the oldest light in existence. Other methods seek to weigh voids directly through gravitational lensing. Light passing near a void bends not because of the presence of matter, but because of its absence. The lack of gravitational pull alters the paths of photons, producing faint but measurable distortions. These signals are among the most delicate measurements in all of astronomy, yet they promise to reveal whether the laws of gravity remain true in the emptiest corners of the universe. Alongside observation, theory marches forward. On supercomputers across the globe, cosmologists run vast simulations of cosmic evolution. They begin with the simplest conditions, the faint ripples of the early universe encoded in the cosmic microwave background. Then, step by step, gravity and dark matter weave their intricate patterns. From these digital universes, the cosmic web emerges, threaded with filaments and hollowed with voids. By comparing the simulations with reality, scientists test whether their models are sufficient, or whether new physics must be invoked. Some simulations explore alternative theories of gravity, wondering whether Einstein's equations might require modification at the largest scales. Others test the influence of different forms of dark energy, imagining universes where its strength waxes and wanes with time. In each case, voids provide the testing ground. Their exaggerated expansion makes them sensitive to small differences in physics. differences too subtle to detect in crowded regions. The frontier now stretches into the future. As Euclid, DESI, and LSST gather their maps, and as supercomputers refine their digital universes, humanity edges closer to an answer. Will voids confirm that dark energy is a simple cosmological constant, an unchanging property of spacetime? Or will they reveal something stranger, a dynamic field, a new force, or a breakdown of the laws of gravity themselves? The boat's void, once a silent scar in the cosmic map, now becomes a stage for the deepest questions of physics. It is no longer an absence, no longer a curiosity at the edges of observation. It is a frontier, a place where light, matter, and theory converge to test the boundaries of knowledge. And perhaps, in the silence of the void, the universe is whispering its most profound truths. That emptiness is not the opposite of existence, but a canvas upon which the fate of reality is written. The boat's void remains, above all, a cathedral of silence. It towers not in stone or in light, but in absence. It stretches across hundreds of millions of light years, an emptiness so profound that the mind struggles to comprehend it. Galaxies should gather in their countless billions. There is almost nothing. It's only a scattering of faint, isolated islands, adrift in seas of darkness. In contemplating this void, a mirror appears. For in the fragile spark of human thought, the universe confronts itself. Humanity has long been captivated by light, by stars, by galaxies, by the radiance of creation. Yet in truth, the cosmos is defined less by what shines and more by what does not. Emptiness is the dominant feature. For every galaxy, there are stretches of darkness so deep that they make all light seem rare, all life improbably fragile. The paradox is stark. It is the nothingness that defines the shape of everything. The cosmic web, with its filaments, walls, and clusters, exists only because of the hollows that surround it. Without the voids, there could be no structure, no contrast, no balance. Emptiness gives form to the universe. Silence gives music to the symphony of stars, and so the question arises: are voids truly absence? Or are they presence in another form, the very fabric of space itself, unshaped by matter, unswayed by the dance of galaxies? Perhaps the void is not lacking. Perhaps it is fundamental. A reminder that reality is woven not only from particles and forces, but from the vast stage upon which they play. In this reflection lies something deeply human. To gaze into the boat's void is to confront the same questions that echo in philosophy, in art, in the fragile arc of existence itself. What does it mean to be surrounded by silence? What does it mean to exist in a universe where emptiness dwarfs creation? The answer may never be simple, yet the act of asking reveals something of who we are. In the silence of the void, humanity finds not despair, but wonder, not futility, but perspective. The very fragility of our place in the cosmos becomes a source of meaning. The boat's void, the largest known emptiness in the universe, is not just a place. It is a reminder that the structure of reality is written as much by what is missing as by what exists. Reminder that the universe is not only a story of light, but also a story of darkness. And within that silence, the search for meaning continues. For in gazing into the void, humanity discovers itself small, fragile, but unafraid to ask what lies beyond the stars.